Hello guys and gals, my name is Dr. Pettis at Dr. P Learning. At this channel, I teach project-based and hands-on CTE and STEM content. We focus on engineering-based projects, CAD, and 3D printing. If that is of interest to you, you're at the right place. Please like and subscribe to the channel so you can be notified when a new lesson is published. Okay, so let's get into today's lesson. In today's lesson, I'm going to be teaching about the basics of electrical breadboarding and how to use a multimeter to take readings of voltage and resistance. All right, let's get into today's lesson.
So the first thing we're going to go over is the two major components that we're going to be working with today. On the left, I have a digital multimeter. With this digital multimeter, I can test voltage. You'll notice that there's a V here for voltage. And don't get overwhelmed by all the numbers and letters here. I'm going to explain some of those today. And then the other component we're going to look at here is a breadboard, a very simple breadboard. You'll notice that there is a column with a plus, a column with a minus, and then you have rows here, row 1, 2, 3, so on and so forth. And I'm going to talk quite a bit of detail about the breadboard. These rows of plus and the rows of minus are all connected. So what does that mean? That means if I have power going from pin 13 here, and I have this also grounded properly, it will light up the LED. No matter where I move it, it should light up. There's also a divider here in the middle, so I'm pointing at it here with my finger, and there's a green line here that actually denotes this divider. So there's actually two different sides of this breadboard. There's an area F through J and 1 through 30. No, we're not playing a bingo. Same thing on the other side. There's a plus column, there's a minus column, and it would be no different on this side. Put that there. You plug that in there. You plug that in there. Same thing. Now, what's different about the rows and columns here in the center of the board is that they're connected differently. So instead of being connected as a column B, column C, they're actually connected by rows 1, 2, 3, 4, so on. So in this case, I'll put the long stem in column 1 and the shorter stem in column 2. So column 2 is a short stem, so that's ground, that's the black wire, and the longer stem is in 1, and that's the power wire. Your light does turn on there. You try to put both in row 2, they would only be getting the ground. You try to put both in here, it doesn't make sense because they're both just getting power. It only works if long stem there, short stem there. So long stem, short stem, and voila, it works. No, this is not a French glass. I want to show you what does work. I want to show you what doesn't work. I want to show you what is connected, what is not connected. The rows here are what is connected. So row 18, row 20, row 25, row 27. And actually, if you look here, this would be row 27. This would be row 25. We skip a few rows. This would be row 20. This would be row 18. So in this specific example, we're using the rows to set up our electricity to travel through in and out of these various components. So I have, again, the power is in this column, the ground is in this column, so the power is going down to this gray jumper. This jumper is going from the power column to A30. So now the power is, instead of going in this column, now the power is in this row. The power is going in row 30. So we have row 30 going to a resistor here. It's going up. It's actually coming down. And again, we're still in row 30. If we go to the ground side's a little simpler. Ground side will go down, connect it to the other side. Gonna connect my ground, gonna connect my power, and there we go. Our light is now on. This is where we will determine what our voltage is. The multimeter also comes with a couple of cables. At the end of each one of these, you will notice, so one is a kind of an L shape. There's a little stopper here, so you need to pull that out and not drop it on the floor. And then the other side is, we'll pull this off in just a minute, but you do want to make sure when you're pulling this side off, because this is extremely sharp and it can draw blood. So we'll leave that plugged in. This part will go into the, right here where it says 600 V max com. This is basically our ground. So we'll plug it in right there. Pull this off carefully, make sure you don't drop it. Set that down. This side will go into here where it says V omega MA. So voltage, resistance, and then milliamps. And we'll talk about amperage later. We're going to test the voltage. In order to do that, we'll need to take these off. Again, they do fit snug on there, so please be careful when you take them off to not hurt yourself. Take both sides of them off. What you're going to want to do is you're going to, again, want to find where you're measuring voltage. We will set this to 2. So we'll set this to 2 volts. Red is the power side, the plus side, and the black you're measuring the ground sides. So you see how it does that? That 1 and that dot. If you measure and you get that 1 and that dot, that means that you have your setting incorrectly. This side first. Touch this side. It looks like with this resistor, 1.92 volts. All right, so we're going to do kind of the same thing, but without a resistor. Turn up. You may need to go from 2 to 20 volts. So basically now you can measure anything up to 20 volts. Okay, so we can apply again. You see here now that this LED without a resistor is 2.34 volts. Okay, so for measuring voltage, of course, you do have to have the power turned on. It's quite the opposite for resistance. To measure resistance, you actually need the power to be turned off. So you don't need to unplug your Arduino. What you can simply do is pull this pin, and the lights turn off. The next thing that you'll need to do is make sure that your multimeter is gone from voltage to our Greek symbol here, which is omega. Okay, we will change that from there to, we'll put it on the 2K. And that will be quite enough for us to measure this resistor. So this resistor here, it doesn't matter which side you put this on. So R equals 321, so 321. So that is what the resistance is in this. So again, I'm going to show you. Let's set the multimeter aside just a second. I'm going to show you that the power here, brighter light. This light is not as bright. You might be saying, well, Okay, but this power is closer to this light than it is to that light. Okay. All right, fair enough. Let's actually do this then. Let's unplug this. Okay. We'll move this light all the way over here. Okay. We'll move this light. Let's actually put it right here. And you'll see that it doesn't matter. This light is still quite brighter than this light here. Okay. The voltage is the push. This resistor is resisting that push so that not as much of the electricity, as you can tell down here, 1.92 volts, makes it to this LED, whereas 2.3 volts make it to this LED.
I want to thank you for visiting Dr. P Learning. Please remember to like and subscribe to the channel. We will see you on the next lesson.